So, hey guys, today is day one of my DSA again, and the day today, like, is it's past 12, so that's why it's 10. But today's date is 9th of August 2026. So today I did this problem, sort colors. It's a medium problem, and the problem states that you are given three different kinds of colored objects, and you need to place them in order so that same color objects are adjacent to each other. Uh, Suppose there are red, white, and blue colored objects. So all the red color objects are placed together, and after that, white color objects are placed together, and then the at the last, all the blue color objects are placed together. So this is what we needed to do. And instead of like instead of taking these red, white, and blue color objects, the question asked us to use these integers like 0, 1, or 2 respectively to these colors red, white, and blue. So we have to place these numbers in order or in place such that all the similar numbers like zeros, all zeros are placed together adjacently or like besides each other, and then after zeros, there will be ones, and after then there will be twos. So uh, if you think of the brute force approach, so what do you think, like how can you do it? Like, okay, let's say, like, what I can do is I can iterate through the array which we are given and count the number of zeros, ones, and twos. And after that, what I can do is I can iterate through the I can make another array, and then what I can do is I can put all these values together, like in order, and together, like all the zeros first and then the ones and then the twos. So yeah, this is what we did in the brute force approach. We first What we did is we first initialize these counters, and then we iterated to the array nums, and then we stored the count of these numbers, how many times they appear in the array, and then we override. Like, what we did is we override the array, and we override the array, like, okay, with the counted values. So until the count of zero is not zero, we put the zeros, and until the count of one, it's not zero, we put the ones and then the twos. But what we thought of is there a better approach for this? Then we found out, okay, yes, there is a better approach. So in this approach, I thought, let's not do that, and let's not iterate through the array once again and place the elements just there. What we can do is make it simpler and put three counters to count the numbers zeros and ones and twos. When we get this number, we can change the same array. Okay, I know we did overwrite in the same array in the brute force approach also, but here we had like here we did the same, but in a different. What we do it is we place the for loop, and then we place the numbers, and it was good, but it's kind of similar. It's kind of similar to the brute force approach. So I thought, why not get a more optimal approach for this? So for that, I found out. Uh, I remember this algorithm which I have seen before. Like, it is called the Dutch national flag algorithm, and in this we initialize three counters or pointers, and these three pointers are like, one is low, middle, or low, mid, and high. Low is initialized with 0, mid is also initialized with 0, and high is initialized with the last element of the array. Low can be said that low is the first index of the array, and high is the last index of the array, and mid is the middle index, but in the starting or in the initialization process we initialize it with 0. And when we find here, what we do is we do not need to iterate through the whole array, and then iterate through the counts of these zeros and then place it or overwrite in the same array. But here we just need a single iteration, and we will place all the zeros, ones, and twos at their respective positions. So what we did is we we started with mid equals to 0, and we checked if the middle value, or like the value at the mid index in the array, if it is 0, then we swap this value with the value at the low index, just like which we did here. If we found out that the value at the mid index is 0, we swap this value with the element or value at the low index, and then we increment the mid and the low index. And if we find that the value at this mid index is 1, then we increment the value of mid, because we wanted 1 to be placed in the middle, or can say it is already at its correct place, so we do not need to swap it with any other place. And at the last, if we find the number or the value at mid index to be 2, then we swap it with the high, or with the value at the high index. and then we decrease the value of high index, or we decrease the value of index high, and that's how we get the same array in corrected. We get the same array corrected in a single iteration, and the space complexity is much lower in in the optimal approach, and it is same in both the other approaches, like the better one and the brute force, and the time complexity is same in all three approaches. So yeah, this is what I did today. Thank you.